Hello students, welcome to Smart Engineering Tutorials. Today we are going to see another topic of Unit 1 of the subject Communication Systems. In our last video we talked about random variables and we saw that actually the random variable is a function which is used to assign a real number value to each sample point of a sample space of any random experiment. So today we are going to see the probabilistic description of that random variable. Let's say there is a probability of a random variable that it has a value equal to or less than x of any random experiment. So this probability is written as P. Inside the bracket we'll write that the random variable has a value less than equal to small x. The small x is actually a dummy variable. So this term is called as the cumulative distribution function CDF and it is written by F, capital F. In suffix you have the random variable capital X and inside you have the dummy variable small x. So this cumulative distribution function Fx of small x is the probability that random variable capital X takes values less than or equal to small x. Since it is a probability, so we know that the probability value lies in the range from 0 to 1. So it also holds for this CDF. This CDF is also called as the simple distribution function of the random variable capital X. Now there are few properties of the CDF which we should know. The first property says that the CDF is greater than or equal to 0. This is very justified thing because it is a probability, so it can be minimum value 0 or greater than that. The second property says that the CDF or Fx of infinity, this means that is equal to 1. This means that the probability that the random variable has a value less than or equal to infinity, since the maximum real number value can be of infinite. So the probability that the random variable has a value less than this or equal to this is 1. This is a certain case in which the probability is 1. The third property says that Fx of minus infinity. It means that the probability that the random variable has a value less than or equal to minus infinite is 0. This is 0. It is very clearly understood because the random variable having a value less than minus infinity or equal to it, it is nearly impossible. So it will have the minimum value of probability and that is 0. Now the fourth property says that the CDF is a non-decreasing function and we need to prove this. How we can say that it is a non-decreasing function? So we are going to take 2 points, say the value of this random variable is x1 or x1 and x2 on number line, and we say that this x2 is greater than x1. So for this we have to prove that the point x2 is higher than x1 as we have written here. So for this condition, this Fx of small x1 is less than equal to Fx of x2. So we have to show that Fx of x, the CDF is a non-decreasing function. It means that the CDF at a higher value, that is x2, it will be greater than that at a value of smaller x1. So the proof for this is that we'll take from the RHS. So at RHS we have Fx of x2 and it can be defined in terms of probability that it is a probability that random variable x will have a value less than or equal to x2. This is the real number. So we can write or we can break this into two parts, that this random variable having a value less than x2, we have another value of x1 on the number line, means the value of random variable is x1 less than, which is less than x2, since we have taken this as assumption. So probability of random variable having a value less than equal to x1 and union, that the random variable value x has a value from x1 to x2, and here it is the equal sign. So we have broken this term into two parts, and this is the union. These two are disjoint. So these two are disjoint, so we can also write them, since we know that the probability of two disjoint events is equal to the sum of their individual probabilities. So we can write this as probability of random variable having a value less than or equal to x1 plus probability of x1 less than this random variable value, this is the range, less than or equal to x2. So actually what is this? This is CDF of x1. So we can write it as fx of x1, this term, plus, and this is the probability that random variable x is having a value from x1 to x2 and equal to x2. And since it is a probability term, so this cannot be negative. So this fx of x2 has come to be the sum of fx of x1 plus probability of this condition. And we know that this whole is a positive term. So we see that fx of x2 is greater than this term by this quantity. Hence it is proved that fx of x2 is greater than or equal to sign will come when x1 and x2 are equal. Then fx of x1. So it is very clear from this. We have proved that the CDF of x2 having this random variable x having value x2 will be greater than or equal to than fx of x1. So it is a non-decreasing function, and we have assumed that x2 is a higher value than x1. And these all the properties hold for both discrete as well as continuous random variables. So in this we have just seen what is CDF and its properties, and in our next video we are going to see a numerical for random experiment, and in that we are going to see how to plot a graph of CDF as well as of probability. So please share and subscribe to my channel for further notifications. And this was all for today's lecture. Thank you.